Today we're going to look at operations with fractions. When adding or subtracting fractions, the fractions must have the same denominator. The reason for this is the denominator describes how the whole has been divided. So different denominators describe different ways of dividing the whole. It's very difficult to add, just as we have here. If we've added a quarter and 2 quarters, that's very easy. We've got 3 of those quarters. But if we've got 1/6 and 3 quarters, it's a bit more challenging because we've divided one thing up into 6 and the other thing into 3 quarters. So we can see we've got 3 quarters. We've probably got a bit more than 3 quarters, not quite a whole, but it's not very exact. So we don't exactly know. We need a method to be able to work this out, and this is how we do it. So firstly, you need to use the lowest common multiple of the denominators to find equivalent fractions. So remember, the lowest common multiple is the smallest number that you can multiply up to for both numbers. So for both 6 and 4, we can multiply 6 by 2 to get 12, and we can multiply 4 by 3 to get 12. So the lowest common multiple of 6 and 4 is going to be 12. We can multiply up. So it's the lowest number that has them both as factors, that has both 6 and 4 as factors. And the easiest way to find a multiple of both 6 and 4 is to multiply them together, 6 times 4. 6 times 4 is 24, but it's not the lowest common multiple. The lowest one is 12. We can do 6 times 2 for 12 and 4 times 3. So then we find the lowest common multiple of the denominators and then find equivalent fractions for both of them. So we'd find an equivalent fraction that has 12 as the denominator and an equivalent fraction that has 12 on the denominator here. And that solves our problem. Then we've got the same division, the same way of talking about these fractions. We've divided the whole up into the same number of parts. So then we just need to add or subtract the numerators. But we keep the denominators the same. The reason that we keep the denominators the same is because they're a description. It's a description of how we've divided it up. If we were to add the denominators together, we get a different number, and it's a different description again. So we need to make sure that we describe these amounts in the same way, and so we describe them with the same denominator. So then we just need to simplify if necessary. So we've got half plus 2/3. The lowest common multiple of 2 and 3 is 6. So we can find the equivalent fraction for a half with 6 on the bottom. So if I multiply 2 by 3, I get 6. 1 by 3, I get 3. So 3/6 is the same as a half. Then we add, we need to find 6 for the denominator here as well. So we multiply by 2. 3 times 2 is 6 there. And 2 times 2 is 4, 4/6. So then we simply add the numerators. Here we've got 3/6, and we add 4/6 to that. So then, in total, we have 7 of those 6s, 7/6. So just a couple of quick examples here. If we've got 3/5 plus 4/5, the denominators are the same, so we just need to add the numerators. So 3 plus 4 is 7/5. Here, we don't have the same denominators, so the lowest common multiple of 3 and 4 is 12. So 5/3 with a 12 as a denominator. If we multiply by 4, we get 12. Multiply 5 by 4, we get 20. So 5/3 is equivalent to 20/12. Minus, so we're subtracting, 3 quarters. We need to get that as a 12 on the bottom, so multiply by 3, multiply by 3 on the top, we get 9. 20 minus 9 is 11/12. Second example here. So here we've got to calculate two values, and we've got mixed numbers this time. So there are 2 ways of doing these, but I've only had a look at one way, which is just converting to improper fractions and then doing what we have been doing in the past. So converting this mixed number to an improper fraction. 3 times 8 is 24, plus 5 is 29 over 8, and 4 times 2 is 8. 8 plus 3 is 11 over 4. So here the lowest common multiple of 8 and 4 is 8. So 8 times 1 and 4 times 2. So multiply the top and the bottom, the numerator and denominator, by 2, and we get 22 over 8. Add the numerators, we get 51 over 8, and then that back as a mixed number. 8 goes into 51 6 times with 3 left over, 3/8 left over there. So 6 and 3/8. For this one here, converting from mixed numbers to improper fractions, we get 2 1/2 is 5 halves, and 1 5/6 is 11 sixths. So 5 halves minus 11 sixths. The lowest common multiple of 2 and 6 is 6. So we don't need to do anything to this fraction, but this one we need to multiply the numerator and denominator by 3 to get it. So times the top and the bottom, the numerator and denominator by 3, we get 15 over 6. And so then we've got the same denominator now, so we can subtract the numerator from this one from that one. So 15 minus 11 is 4, 4/6, and we can simplify that. We can simplify 4/6 to 2/3. Okay, so when multiplying fractions, we multiply the numerators together and multiply the denominators together. It's very simple. So 1/2 of 3/4 is actually a multiplication problem means multiply. So 1/2 of 3/4 is the same as 1/2 times 3/4. So 1/2 times 3/4, 1 times 3 is 3, 2 times 4 is 8. Very simple, 3/8. But when we're dividing fractions, this one's slightly trickier. We need to multiply the first fraction by the reciprocal of the second fraction. So reciprocal means we switch the numerator and denominator. So here, 4 over 1 is the reciprocal of 1/4. So 3/4 divided by 1/4 is equivalent to, it's equal to 3/4 times 4 over 1. See, we've taken the numerator and denominator and we've switched them. So 3 times 4 is 12, and then we simply do this. We multiply the numerator and denominator. 3 times 4 is 12, 4 times 1 is 4, and 12 over 4 is 3. 12 divided by 4 is 3. Here we've got another example. So calculating these multiplications here. So 2/5 times 3/7, multiply the top line, 2 times 3 is 6, and multiplying the denominators, 5 times 7 is 35, 6/35. Very easy. Here 8/5 times 7/4, 8 times 7 is 56, so that's the numerators multiplying. Denominators multiplying, 5 times 4 is 20. Now we can simplify it down, and divide both the top and the bottom by 4. So dividing the top by 4, we get, the numerator by 4, we get 14, and the denominator by 4, and we get 5. So 14 over 5, and that's the simplest form. So here, we need to convert these mixed numbers, for this one here, we need to convert these mixed numbers to improper fractions to be able to multiply the numerators and the denominators. So 3 and 1/3 is 10/3, multiplied by 2 and 2/5, which is 12/5. So 10 times 12 is 120, 3 times 5 is 15, and that can simplify down to 24 over 3, which is 8. We can even put this into our calculator, and 120 divided by 15 will yield 8. Our very last example, so we've got 3 divisions here now. 2/5 divided by 3/7. We need to multiply by the reciprocal of the 3/7 here. We need to reciprocate the 3/7 there. Note, we'd never do anything, we don't find the reciprocal of the first one, only the second one to make it a multiply. So it's only this last bit that gets changed to a multiply, and it'll be 7 over 3 rather than 3 over 7. You can see the 2/5 is exactly the same. So here, this 2/5 divided by 3/7 is exactly the same. It's equivalent to, it's equal to 2/5 times 7/3. So 2 times 7 is 14, 5 times 3 is 15, 14/15. Secondly here, 5/8 divided by 15/16, that's the same as 5/8 times 16/15. We found the reciprocal there of the second fraction. 5 times 16 is 80, 8 times 15 is 120, and that simplifies down to 2/3. So if we divide the top and the bottom by 40, divide the top and the bottom, the numerator and denominator by 40, we get 2/3. Lastly, we need to convert these mixed numbers here to improper fractions. So this as a mixed number is 9/4, and this as a mixed number, as an improper fraction is 4/3. So 9 quarters divided by 4/3. That's equal to 9 quarters multiplied by 3 quarters. So 9 times 3 is 27, 4 times 4 is 16, and 27/16, that can be converted back to a mixed number, which is 1 and 11/16. You might notice that occasionally I have converted back and forward between mixed numbers at the end. It's really personal preference. This is just as right, just as correct as this. However, when I've been given a value in mixed numbers, 1 and 11/16, it seems right to convert it back to a mixed number at the end. But as I said, it's personal preference.